Hi there, I'm Clint, and today we're going to use the SDK for Java provided by the OpenZiti project to securely and access a Postgres database in a zero-trust fashion. In order to do that, we're going to need an environment. This is what the environment will look like. You can see I have a Windows-based operating system. That Windows operating system will have Eclipse pre-installed, which is where I'll have my Java application. That Java application will reach into a Linux virtual machine container in order to contact these public edge routers. And then these public edge routers will then communicate back through the private blue router into the Postgres database. And that's the logical flow of how the data will actually traverse the network. But those private routers, private blue and private red, they're referred to as private because they have no link listeners. That means they will not accept an inbound connection. In order for the blue or the red router to be used, the blue router will have to establish a connection to one of these three link listeners, as will the red, as will the gray. And then the traffic will have to traverse this Ziti overlay network using one of the paths pre-established. So these private routers are hidden from the entire network. You cannot create a connection to these routers nor to Postgres. The Java application will connect to the private routers, and then when trying to send data, that's when the Ziti network will decide which path to follow. So this is one of those possible paths. Another possible path might be through the other edge router, and another possible path might be no transit router involved and just straight into this blue router just like this. Ziti will decide. Once your traffic is on the overlay network, the smart routing feature of the Ziti fabric will take over and will route your traffic through the path which is fastest automatically for you. Nothing to do on your end. Okay, so that's the environment. That's what we're going to do. Let's actually go ahead and do it. So here you see my Linux virtual machine. I have three windows. In the left window, I'm going to run Docker Compose, and you'll see all that fly by. And then these other two windows are just for ancillary commands. First thing I need to do is clone that Git repository. So I'll make a directory called demo, cd to demo, clone that repository, cd into Ziti, quick start, Docker, and then vi that Docker Compose file. And I need to vi it or edit it because I need to add this little section right here. And feel free to peruse this compose file. You can see it has all those pieces I talked about. And now it has the Postgres piece. And now I'm ready to go ahead and start this network. But let's make sure that it's not already running. It is not. Fantastic. And let's go ahead and start it up. Now, in the meantime, while that happens, I'm going to use Docker and I'm going to attach, if we recall, I'm going to attach back to this blue router because this blue router has access to the Postgres database. And right now, I want to bootstrap that database. So I'm going to install the Postgres SQL client. This takes about 15 seconds. So in the meantime, we can sit here and contemplate, watch the pretty colors go by, watch the console do its thing, and eventually it will complete. I have faith. Okay, it's complete. Now let's go ahead and connect to Postgres and put in our password. All right, now we're connected to Postgres. Now I need to bootstrap this database. So I'm going to make a database. I'm going to make a table. And then I'm going to insert some data into that table. And then finally, I'm just going to select that data back out just to make sure it works. And bam. Okay, that's what I should see. Now you've seen me connect to Postgres from within the Docker container using psql -h Postgres database Postgres. So I'll try that outside of the Docker container. And you can see when I do that, I can't access the Postgres database. This is because the host names for Docker Compose are contained within Docker. So you have to jump through some hoops in order to expose the Postgres database as a name that you can resolve. But a lot of times that port can just be exported localhost by Docker itself. So you can see here, I can also try to attach to it and not have any success. And finally, I can prove that Docker is not exposing a port by finding the Postgres database and just seeing that the port 5432 is not actually exposed by Docker. So right now that Postgres database is locked deep inside of Docker. No access to it from the outside world. And now I have set up Docker, proved that it's dark. It's not listening, you can't get there. Okay, and now I want my cheat sheet. And I'm going to make sure that Ziti is on my path. So that was one too many exits. Let's make a new, okay, this is not going to plan. Let's make a new window. There we go. Let's do it down here. Okay, so now this is going to pull down the latest Ziti, put it on my path. And we need the Ziti CLI because we're going to run some Ziti CLI commands to bootstrap our brand new fresh environment. Remember that we created this whole environment 3 minutes ago. And so now we need to do some initial bootstrapping type work. Some of that bootstrapping is going to be right here. This is where we create our service and our configuration and our terminator. So to create the configuration, the important part of the config is actually right here, this Zitified Postgres. Remember Zitified Postgres because when we go back and look at the JDBC URL, this hostname that we create in this config is going to be what we add into the JDBC URL. We're going to make a service called private Postgres that uses that configuration called private Postgres config, and we're going to add an attribute called private Postgres services. And an attribute is just kind of a way to group your services together. Not really necessary here, but I'll be doing this for illustrative purposes only. And we're going to make a terminator. What's a terminator? So in order for traffic to exit the Ziti network, you need to terminate somehow, meaning tell me the node that you want my traffic to exit on. Since Postgres is inside of this blue network, we need the traffic to exit on this private router. So that's going to be the router, which we tell Ziti to exit on, Ziti private blue. So let's go ahead and make those things. 1, 2, 3. Oh, let's run them down here with the command. Okay, let's log in first. There we go. Okay, now that we've logged in, now we can run these commands. Okay, fantastic. Let's see. So now we're going to make a service policy. And what a service policy does is it basically says these identities can access these services. And so if you recall from before, I had given the service the attribute of private Postgres services. You can see it right here. Okay. And so basically what this is saying is any identity that has the attribute of Postgres clients, which we don't have any identities yet, spoiler alert, we're going to make some, those will be able to access this service. So let's go ahead and make that policy. Okay. Now I'm going to make an edge router policy. And what an edge router policy will do is it will tell you which routers, in this case the green ones, an identity is able to use. And I'm going to use the identity for the one I will create in Java. And so let's say, remember Postgres clients from before? We've authorized services. Well, now we're going to authorize which edge routers they're able to connect to. Okay. And then finally, we need to overlap the service, the routers that an identity can access with the routers a service can access. And since the services are hidden, locked away, we can give them only access to the public edge routers, the same as our identity itself. So we're going to go ahead and do that. All right. Now, the compose file does not add any of these attributes to your routers for you. So if I come over here and I do a Ziti edge list routers or edge routers, you'll see I've got a bunch of edge routers listed here, and they have no attributes. So I need to add some of those attributes because these attributes are used in other policies and whatnot. And in fact, I think I actually don't need the blue routers. So we're going to do it live, and we're going to just add this one attribute, this one edge router. And you'll see that now this Ziti edge router has public edge routers as an option. Okay, so that's all our bootstrapping. Now we're going to make a new identity. This identity is going to be used by the Ziti tunnel API just to prove that we've set everything up correctly before we actually go and run our Java app. So now I have, let me bootstrap the other terminal window so that Ziti's on the path, okay? So now I've created an identity. I've called it tunneler ID, and I've put it at this path here. And then I'm going to use the Ziti tunnel in proxy mode just to prove to myself that I've set everything up correctly. Ziti tunnel in proxy mode. Give it the identity. That is not the identity. This is the identity. And I'm going to use a service. Let's see, what's the service called? Well, actually, you know what? I've got the command right here. I just copy and paste the command. Even better. Okay, so now you'll see Ziti is running in proxy mode and listening on localhost 0.0.0.05432. That means it's going to accept connections. And if you remember from before, we tried to connect to Postgres on localhost, and we were not able to. If I've done everything correct, I should be able to log in, connect to simple DB, and then select star from simple table. Look at that. And so now, using the Ziti tunneler, we have been able to prove that our service and policies are all set up correctly. Well, that's great, but we don't want to use the Ziti tunneler, so let's get out of all these. And now let's make an identity just for Java. And there's my identity for Java. On my Linux machine, this /mount vtemp will correspond to my c:/temp. So if you see c:/temp, that's why my virtual machine has a shared folder, just to make it easy for me to do stuff like this. Oh, and before we did mention, I didn't quite mention, but in order to access things like the Ziti Edge controller or the Ziti Edge router, actually I don't want that in there, you need to be able to address these. And the way I did that is just by cat etc hosts. So you can see I've already set up a couple of hosts file entries just so that I can do that. And I did this in Windows too. So if you wonder why you can't connect, you might need to update your hosts file in Windows. Okay, so here we are now in Eclipse. If you recall from before, I said the most important piece of this config is Zitified Postgres. Obviously, it's all important because authorization and authentication is all controlled from these commands that you've issued. But this one is important to the JDBC URL. Zitified Postgres is the same host name that I'm using up here. And port 5432. And I think that is everything. So this is the code. It looks pretty easy. The real key in the Java SDK is to set this socket factory property, which then is used when you create your connection to the JDBC driver. And then you can see I'm going to select star from simple table, and this should all just work. So let's go ahead and run it, see what happens. And look at that. We have results. Those are the proper results. And that's it. So in what, 15 minutes maybe? I don't know how long it's been. We have been able to create that Ziti network that we talked about. We've been able to establish a connection securely through the Ziti overlay network into a Postgres server, which is not listening on any ports that are exposed to any network other than that Docker network, using our Ziti overlay. Pretty cool stuff. That's all we got. Hit us up on Discord if you have any questions. I'll put the link in the description below. And feel free to check out that Ziti project. And if you have any questions, holler at us.